Hello, my name is Michael Bray, and I will be giving you the Week 2 assignment Dimensional Modeling brief. At JetBlue, prices for booking flights are different at each time period throughout the year. If the flight is over 2 months from today's date, how does the price different than if someone books the same flight 2 days before it? Based on geographical location, where does the volume of our travelers choose as their destination? Where do our customers, a majority, fly from? All of these questions can be answered using the dimensional modeling, where we can articulate what data we bring in and how we select to filter it by separate dimensions and distinct fact tables. In order to do this, we have to set up a dimensional design process, which is pictured on the screen. First, the business process. The proposed business process would be booking airfare online solely through our company's website. So we're only going to take data coming in from our booking site, no third-party apps for this instance. By using the online booking, we can capture who is booking with us, where they are coming from, and where they are going. Why, in a non-invasive way, are they booking? Is it for vacation, business, relocation? When would they like to travel, and when are they booking? Lastly, what kind of booking? Is it first class, economy, and so on? Using these parameters of online booking, we can define the factors that dictate a business process from a top level. Next, we declare the grain, where one booking would give us how many tickets were sold. So we're going to use 1 row per online booking line item. This will give us our name, which addresses the who, their address, the geographical location, that addresses the where from, the date they booked it, and an optional field with a drop-down entry for reason for traveling. So that's our why. Pricing will occur as well with applicable taxes and baggage fees, which have their own fields. All of this will be based on a period of time. The dimensions. So we're going to use a type 2 dimension, which means we are adding a dimensional role for correlation with destination, which helps us to address the where to, and the date of travel, again, as a when, which we could turn into monthly, quarterly, and yearly data fields. Ultimately, we can have dimensions for date, geographical location for origination, as well as the destination, and range, which is for pricing and dates that reflect the booking time and travel dates, with pricing being there as well. Lastly, we identify the facts. So given the prospective business process, the grain and dimension, the table of facts would be in a periodic snapshot facts table. A periodic snapshot facts table stores the data that is of a snapshot and period of time. The source data of periodic snapshots facts table is data from a transactional fact table where you choose a period to get the output. Quoted here, we have periodic snapshot fact tables capture the state of metrics at a specified point in time. Periodic snapshot fact tables are used to quickly assess and review the performance of the measures over specified time intervals, essentially for a week, month, quarter, year. We can also do date, specific day of the week, which is prevalent when we talk about booking online and booking for airfare online. If you book on a Monday versus a Friday, how do the prices change? How are they different? Next, we have OLAP cubes, or online analytical processing, which is a category of a database processing that facilitates business intelligence. OLAP provides BI professionals with information that they need to make effective decisions within an organization. OLAP tools can be used to leverage data from intersections of dimensions that live within the database. For example, we can grab all the flights that have been booked in the Southwest region in quarter 3 for the means of vacation as the reason for travel. Typically, OLAP cube is a multi-dimensional array of data that is turned into a cube based on data that exists along the X, Y, and Z axis. The figure to the right displays this concept with location, type, and time. Next up, we have dimensions. So the fact table would be booking underscore data, and that would be comprised of date of booking, date of travel, price of the ticket, departure from the city and state, destination from the city and state, class of seating, and number of tickets. The dimensions to go along with this fact table would consist of date, geographical location for departure, geographical location for destination, reason for travel, and again the range. Below, I have each dimension and what would be consist of in those dimensions. An EDM schema. This shows two different types. You have a star and a snowflake schema. They're the most two popular multi-dimensional models used to model data in a data warehouse. The biggest difference between the two is a star schema does not use normalization of data, which is an effort to reduce redundancy in data sets. This is done by having the data split into multiple tables. Both star and snowflake schemas contain fact and dimensional tables. However, snowflake contains a sub-dimensional table to go along with the fact and dimensional tables. It breaks out even more so than what a star does. To the right, I have a basis of a comparison in both schemas and how they project based on the structure, use of normalization, the ease of use, data model, query complexity, foreign key join used, space usage, and the time consumed in query execution. You can view those. In determining which schema I would use, it would come down to how easy is it to understand each schema, what level of querying skill are required to navigate the schema, and what is the time allotted in the project. To me, a star schema caters to all these points. With a top-down model versus a bottom-up model with a snowflake, the approach is a little bit better than a snowflake, and the level of complexity of the schema is much easier. So, with that being said, it's easy to overlook the redundancies that are provided in a star schema and the memory storage needed to construct it. In conclusion, online booking data derived from our company's website at JetBlue can be modeled in a way that provides insights to our management team for decision making. Understanding the characteristics of purchasing tickets at different time periods, for different time periods, and the respective price points that go along with them will give us a wealth of useful and pertinent information. Pairing this with geographical locations of departures and destinations allows us to better fulfill our marketing strategy on who to target with different pricing options based on specific seasonal events throughout our network of airline travel. Thank you.